Very, very good evening. So, who all we have? Let me check quickly. We have on top of my screen Kripa, Sanvi, Jagat, Hridaya, Pratibha, Gauri, Shweta, Ritesh, Ishant. Wow. And Siona. Warm welcome after Saturday and Sundays. Let's start. Very good evening. Kripa, what are you saying? I am naughty. No, I am not naughty, Kripa. I just saw very, very naughty. I think he's on mute. I'm on mute, but I am not naughty.
No, sir, I was talking about my sister.
Okay. I thought you were telling me naughty.
Or
So
is not.
let's start. So today and tomorrow, last two sessions, we want to do lot of 3Ds. 3D, 3 dimension. Let's start with you people. I believe everybody would have done attendance, so I'm not checking. I trust you. If you're not done, do it. So let's start with Hridaya. Hridaya, good evening. How are you?
Good evening, sir. How are you, sir?
I'm good. Tell me any 3D figure.
3D figure. A pencil.
Pencil. Okay. Tell me, Pratibha, any 3D figure. Tell me, Sanvi, any 3D figure. In real life.
White, cube.
Cuboid.
Then cone,
So
cylinder.
let me also write in the term of figure and then we'll do the example. Cylinder.
Cone.
If you tell everything, what others will say, Sanvi? Gauri, any other figures you know?
Sphere.
3-dimensional. Sphere. What else? Ishant?
Triangular prism.
Triangular prism. Okay. Prism kind of thing. What else?
So, Rubik's cube.
Sorry?
So, cube, Rubik's cube.
Correct. That is cube. Correct. What else? Hemisphere. Frustum. What else? Anybody can think of anything else?
Pyramid.
Pyramid is more time of, pyramid. Anything else? Okay, that's enough. Now, I want everybody to give me real example of life. Give me real example of cube first.
The Rubik's cube.
That is Ishant said. You cannot say that. Rubik's cube, Ishant has said. Okay. What else? Tell me, Sanvi. Sanvi, tell me one only.
Sir, I want to show you some live example.
Please.
Sir, dice.
Dice is almost like a cube. Correct.
Sir, even this is almost like a cube.
See, she is so sincere. That's why I say my few students are very sincere. It's also very nice. Anybody else? Real example of cubes.
Sir, tiffin box.
Jagat, I'll come to that. Ice cubes, right?
Yes.
You also saw sugar cubes, mostly sugar-free kind of thing. Sugar cubes also sometimes cubes, right? Okay. So what about cuboid?
It's a box.
No, this time I want different people. No, I want different people now. Kripa will say, Siona will say, Pratibha will say, and Ishan. These 4 people will give me 2 example each. Cuboid example.
It is a box.
First, Ishant, tell me 2 examples. Ishant.
So it is a new one. New eraser.
New eraser. Old eraser becomes rounded from the corners. Very good. What else?
Ishant. So then, box, cardboard box.
Cardboard box. Most of the time it is cuboid only. Cardboard box. Okay. Now, Siona, give me 2 examples of cuboid. And everybody else should be on mute. Siona, 2 examples of cuboid.
A book.
Book is a classic example. One more.
A brick.
Say again, sorry.
A brick.
Sorry, I am not. Spell it out.
BRICK.
Brick, correct. You are right. Brick is good example. Thank you, Ziona. Then Pratibha, give me 2 examples. Tanvi, you already finished your quota of today.
Sir, juice box.
Juice box, juice box, juice box. Maybe, may not be, depending upon which one you are home. I don't know, but it may be.
Matchbox.
Matchbox is good example. Okay. Anything else? Sanvi want to show from so long. Sanvi, are you using lighter? What, Sanvi? What is that?
Sir, this is a chocolate box.
Oh, that mint, that something what?
Tic Tac.
That also is not good for you. No.
No, sir, I don't eat it. This is old, very old.
Don't touch it also. Okay. Don't touch it also. Okay. Yeah, that's better. But good guys.
I have one more. This is just a type of brick.
Very good. And you know why I'm very happy? Because see, I told last class, bring objects. And she is my most sincere student now. Earlier it was Kripa and Hridaya. Now you have taken the place today. You got so many objects. That's so nice, Anvi. So good. Now cylinder, Gauri. Cylinder. Okay, let me unmute everybody, but only one person will talk at a time. And only the person who I telling. Gauri, tell me 2 examples of cylinder in your home. Your home, Gauri.
Water bottle.
Water bottle. Many times it is. Yes. Many times. Not always, but anything else?
Gas cylinder.
Gas cylinder. Yeah, it looks like one part of it. What about Hridaya? Tell me 2 examples from your home.
Sir, with me now is pouch.
Pouch.
Yes, sir.
Show
It
me.
will be.
Where is
Now
that?
I'm not like this one. The earbud.
Correct. Pouch. So again, what else?
Then, sir, that medicine that like.
Again a bottle. Any bottle also can be. Most of the bottles are round. Oh yeah, Shweta is showing something. Shweta, it's a pickle.
It's a medicine bottle.
Oh, I thought it's a pickle or something. Okay.
Sir, even I have something.
Cylinder,
Pen.
markers, yes. Pen, pencil. Correct?
Yes.
So many examples.
Sir, our
I
kajal.
want to get some different examples from Ritesh.
Sir,
Yes, please.
sir, kajal.
Kajal. You are all showing your items. Very good. Kajal. Okay. Do you wear that?
Sir, pen stand.
Pen stand. Okay. Kripa was missing. Where is Kripa now? Cylinder. Very good. Now we'll come to cone, which Ritesh will start. Ritesh, I know less examples in life, but still cone examples. Jagat and Ritesh both will tell 2 to 3 examples. Example of cone in real life.
Ice cream cone.
Which one?
Ice cream cone.
That is the most common example. Very good. Ice cream cone. What else?
Traffic cone. Traffic cone.
The traffic people use that, right? Traffic cone. That. Correct. What else?
And Christmas tree.
Christmas tree is also sometimes, yeah, it becomes a cone. Very good. That's the one of imagination. What else? Ritesh, are you there?
Yes.
Think anything more you can think?
Birthday cap.
I was about to say that Joker or birthday cake, right?
Sir, even I was going to say.
Sir, even I wanted to tell something.
Tell me, Kripa.
Bell, temple bell.
Almost. See, bell is almost, not always. Bell will more come into a frustum kind of thing, but I'll explain that. What frustum? Let's write bell also. Very few doubt. What else?
Sir, carrot.
Carrot. Oh, carrot. Oh, that's a good part. Yeah, carrot also many of the time. Oh, that's good imagination. That's what I'm loving it. Okay. Spare.
Radish. Sir. Radish
Also. You are right. So now we'll go to spare. Spare is, who will tell me who is this? Gauri, Ishant. Ishant and Sanvi. Spare.
I'll say, sir, or you will start first?
You can say it. Till Ishant think about it.
Sir, ball.
Ball. So many, any ball you can say.
So one.
The moon.
Oh, she has all the
The moon.
objects with him, her. You know? Tell me, Shant. Tell me, Jagat. What
The
else?
moon. Earth. The moon.
Moon,
Earth.
oh, he reached to space. Wow. You know, you are. My son is like that. He's mad about it. You know, my son has. Did I told you or not? My son just completed 10th. He made his own Instagram channel. He's putting some beautiful facts about space, like moon, Saturn, Earth, which I never knew. With some
Wha-
research.
What's his Instagram account name?
His account. I'll message. What was his account? TS.
Okay.
I always forget. I'll ask.
Okay.
Yeah.
So the example for carrot.
Yeah, see the guys. Oh, lemon. Now she's putting lemon also. That's good. I'll give the account that because that everybody will be useful for that. Okay.
Sir,
Okay, sir.
globe.
So
Basketball.
Noted.
So what,
So
what
can-
it is? Spare, lemon, earth, moon, ball, what?
so
Basketball.
Globe. Yeah. Okay, that's enough.
Globe.
You can-
so
yes, please.
there can be candy also. Sometimes.
Prisms are less.
Yeah, like lollipop.
Coconut.
Coconut is all. Okay, it depends. You make it
Which
oval
we
also, you make
drink.
it- you make-
Not the one we use for cooking. The one which we drink. Tender coconut.
Okay. Yeah, it can be. Okay, I am giving that Instagram account for my son. It is this. He has put his name in the starting. TS specific. He is putting some amazing. You will not believe. I mean, I was watching only. I was not. He is very created account, and when he started putting, I never knew.
Sir, I follow him.
Is it?
Yes, sir.
And you saw that he is putting so many words which are even very rare facts.
Yes, sir. Tomorrow he just put about Earth, na?
Yeah, he has put for yes one yesterday, day for yesterday for Earth, then Mars, then Jupiter. So I am loving it when reading it because I never knew that. So anyway, I am not good in geography. I was never good in geography anyway. But still, okay, it is that Instagram. So let's come back. Hemisphere. Tell me somebody hemisphere.
So,
Yes, please.
my favorite subject is geography and social.
Very good, Hridaya. Then you come and join.
But you said,
Come and join him. So hemisphere. Any other object hemisphere can you think of? There are. Have you seen a kitchen? See, Shweta has that already. See, bowl. It's a good example of hemisphere. Hollow hemisphere. Very good. Okay, how many of you know frustum? How many of you know frustum?
I know.
Explain.
So frustum is a part of a pyramid. You just cut the top part and then you get the frustum.
Right, right. If you cut the cone, say I don't have cone, but I'll ask my. Okay, 1 second. Tusham, 1 second.
Sir,
Give me this. I'll give you what is frustum.
symbol of lamb.
I'll show you. Give this. Green. Oh, I have that. Oh, I have frustum.
Yeah,
Wow.
the
See, cone will go up till full, right?
sir lamb.
Cut the cone. It's a frustum.
Excuse me, sir.
Yes, please. Frustum.
Sir, if you take the shuttlecock which we use, take up that part, it will even that become frustum.
Correct. Cut shuttlecock. And Kripa also saying correct.
My
even
sister's clay container.
So all those. Yeah, ice cream container there. Those are actually frustum only. Yeah, glass is one of the good example. Even I had a
Sir.
glass, but it's not a frustum because it's something different. It should be straight. But you are right. Superb. And pyramid and prism.
Sir,
Correct.
that lambs that cover.
Yes. So everybody can relate the 3D objects, right? So today we are going to talk about at least these three. At least cube, cuboid, and cylinder. If time permits, we'll do cone also because this takes a lot of time. So we'll do first this two. Okay. Everybody can relate what are the objects. Now let's come to cube and cuboid. What is the difference between cube and cuboid, Kripa?
Sir, cuboid is like is just like a rectangle, But cube is made up of squares.
So tell me now, everybody, yeah. So cube and cuboid, the only difference is, oh, where is my cube went? I'm keeping my voice against there, yeah. Okay. Yes, that is the, even I have similar type. Cube, all edges or all are exactly same length. Cuboid, not necessary. So tell me, how many faces are there in cube and cuboid?
12 faces.
Now,
6.
see,
Right.
1 second. Tusham, 1 second. Huh? I'll explain what will be useful. Sorry, cube. Give me this cube, please. So I'll explain because that is very important. यहीं पे रखा है you can see this. Cube, right? So what we're going to talk about is face, front face, front and back, top and bottom, left and right. We always will talk like that, okay? Left, right, top, bottom, front, back. 6 faces, correct? Now tell me, how many edges? Who can tell me how many edges?
Edges is 12, I think.
I guess 8.
Okay. Let's see what other says. 8. It is 12, guys. Why you're saying 12? 8 only. Edge. See how many you can see. 1, 2, 3, 4 on top. 4 on bottom. 8, 9, 10, 11, 12. 12 edges, right? Why you are saying 8? Only people, lot of people. 12 edges. Correct? See. 1, 2, 3, 4. 4 here, 8. 9, 10, 11 and 12. 12 edges, right? Convince everybody? Yes. How many corners or vertex? Vertex.
Eight.
It's 8 only. 1, 2, 3, 4, 5, 6, 7, 8. Whichever way. This is cube or cuboid, right?
Yeah.
No confusion. Simple thing, right? Now, when you say faces, edge. Acha, one more thing I'll explain. Diagonal. There are 2 types of diagonals. Face diagonal and principal. Everybody think about some kind of, say, big rod is there, okay? Tanvi, look around your hall. Where are you sitting? Your drawing room, or which room are you sitting? Suppose drawing
Sir,
room.
my where I keep my toys at that room.
Toy room. Sanvi's toy room. Doll room, toys room, study room, whatever. So it is a kind of cuboid or cube?
Sir, it is almost a
Cuboid.
cube.
Almost a cube. Now suppose Kripa has a big rod, okay, some 20 feet rod, some kind of rod, and she want to put that into your room. How will you put? Suppose your height of your roof, like from the floor, is say 10 feet or 15-20 feet. Suppose say 10 feet is the height.
Yes.
And she gives you 12 feet big rod. How will you put?
Sir, I'll cut 2 feet.
No, you can't cut. It's iron rod. She don't want you to touch at all. Gauri, we don't want to cut, Gauri. Kripa is very particular about it. Kripa's, that is a favorite rod. She don't want to cut.
Sir, I know what we can do.
What?
Normally, like when something doesn't fit, what I do is, if this is the end and this is one more end, then I keep it slant.
Yes. So she will put like this, slant.
Like this.
Suppose Sanvi, you see in front of your wall, you see your front wall. In your
Okay,
room,
sir, yeah.
see your front wall, any one wall. If height is suppose say 10, but if you take from say left bottom to top right.
Yes, sir.
It will be diagonal and it will be longer than this, right?
Yes, sir.
So if you put like this, not like this, correct? On
Yes, sir.
around a wall, if you put like this, exactly 45 degree, that is the maximum length it can occupy, right?
Yes, sir.
On any of the wall. But I get much bigger, not more. I got some 13 or 14 feet. How you want to put now? Say even that length is not enough. I have bigger rod. So how will you put Gauri? Or Shweta or Ritesh, anybody? Think what I'm trying to say. Listen very carefully. See, or see this cube? Everybody? If I put something from here and up to here, that is your one diagonal, right? Top left to bottom right. Top left to bottom right, right? But if I put from the front corner to the back corner down, it is more bigger, right? See, from the top left, front, if I go to the bottom right, bottom and back, it's the biggest rod, right? Do you understand the difference
Yes,
between
sir.
these two?
Yes, sir.
And that is a principal diagonal. So listen very carefully. If I put like this, it's a face diagonal. This face diagonal. If I put like this, it's a face diagonal. If I put on this face diagonal. But if I put from this corner, say one end of the rod is this corner, this one, and one end is this corner inside. It's the longest rod, right?
Yes.
It comes from top to bottom, back to up, left to right. That is called a principal diagonal. Is it clear? Shweta, do you want to explain difference between face diagonal and principal diagonal? I want people to visualize it. Unmute, please. Yeah, she will use the object now. Shweta, you are on mute.
Now listen.
See, she has a very good object, cuboid.
So now we got this box. Now consider this as a box. Now you can see even space in it. Look, we
Yeah.
got a space.
Very nice, Shweta.
Yes. So if we put anything like from this end to this end, like which fits on the wall from this end to this, then it is considered to be face wall.
Face wall or face diagonal.
Yeah, because it's on the surface. That's why it's face.
Yes.
Because it's on the surface, that's why on the face. Now we have to fix another rod which doesn't fit this way. So now it is more bigger. So it can fit from one corner. Look, the one corner inside to the bottom another corner.
Outside, yeah.
Yeah, look here.
It's just the imagination.
Yeah.
Very
So
good,
it's
Shweta.
more better.
If you have some kind of big pencil, you can. I know it will be difficult to get exact same height.
No,
Yeah.
No, but like this.
Yeah.
Anything from here to the end of it, I don't have anything like that.
No, I know. That's why I was also strictly. But yeah, main point is, it is not only on the same face, from front face to the back face.
Yes, to this up to here. From here to here, that is a face because it's on the face. It's on the face. Now, when it comes to principle, so like it's starting from here and it's diagonally reaching to here.
Right. From back to front or top to, like, it's always like all the three. Very good, Shweta. So tell me now, everybody, suppose in a cube or cuboid, length of edge or length of face diagonal or length of principal diagonal, which will be the smallest? Very easy, we already explained it. Which is smallest and which is biggest?
Length of edge.
Is the smallest, correct?
Yeah.
She explained already. And I also told you in the starting. And biggest would be?
Principal diagonal.
Principal diagonal.
So everybody can visualize this. And we are going to use this lot. So now you know any 3D figure. Any 3D figure, we always call them solid. Because they are 3 dimensional, they can hold something, right? So like this box, it is not a plane. It's a solid figure because it can hold something. Right? When I say paper, paper is a plane, 2D. But 3D figures are all, they can hold something, right? So we call them solid. Now, in 3D solids, there are two things. One is the volume. Volume means, what volume means? Capacity. How much it can hold. Capacity of a square, capacity of a cube, or capacity of a cuboid, or cone, these are all volume. How much volume it has. Volume is the overall whole internal space, whole full space. That is called volume. And second thing is like about surface area. And I am going to derive this practically. We don't have to mug the formulas. See, many people say, oh, we have to mug so many formulas. We are not going to mug any formula. I'll tell you practical significance of all of them. So when we talk about cube and cuboid, say cube first. Volume and surface area. What volume means? How much it can hold, it can contain, the capacity, or the how much volume it has means. So it has length, it has breadth, it has height. Length, breadth and height, 3-dimensional, right? So volume of any of this figure, cube or cuboid, is always given by length with breadth. It's same thing how you do area of 2D figure, right? Length into breadth. Length into breadth into height. But in this case, length and height will be same, right? So say each of them is A. You can say A into A into A. And that is your, you can say, A cube. A cube is your, or side into side to side is your volume of. So we talk about surface areas. There are two types of areas. One is tell me, suppose this side is A length. What is the area of this face? Tell me, Kripa. The length of the side is A of
Okay,
this
sir.
cube. What will be the area of this face? The face will look like which figure? Which 2D figure?
Length into breadth, sir.
Square.
Square. Because, Shweta, sorry, you said something?
No, I said it's same like a square, length into
Correct.
breadth.
So it's a length into breadth. And both are same. So what is the area of one face, Kripa? A square, correct?
Yes, sir.
A square. What is the area of the back one?
So that is also a square because
What
everything
about
is
left one?
same.
Right. So how many lateral faces? Only 4. Left, right, front and back. So surface area has two things. One is lateral surface area. There are 4 lateral surface area. Front, back, left and right. Like walls. 4 walls. So it is,
Sir, not up and down.
I'm coming to that. It is lateral. I'm not talking about total. We come to that. 4A square. When you say lateral, we don't count up and down. Lateral. We don't count up and down in any figure. But if you want to find out the total surface area, you take all the 6 faces. The total surface area would be how much?
6A cube.
6A square.
6A square, sorry.
Getting it, everybody? The difference? See, more than the formula, what I want is, I want you to understand the, because I am going to give you questions which are not, you will not use formulas, you have to use some concepts. And we are going to do it today. So, lateral surface area does not count top and bottom. And otherwise it is all 4 face. Clear?
Excuse me, sir.
Yes, please.
Sir, A means area, no?
A means the side, length of the side. A, just we take A. We can take X also, Y also. A is the length of one side.
No, because here you wrote A into S, so I thought.
Hi, everywhere I'm using A only, see. The standard way in every book will say A only.
Okay.
You can use X, because if I use X, X and cross will look same. Okay. So A is the length of one side of cube. So clear about LSA and TSA? T as a total surface area, L as a, because I am going to give you two practical question, okay? Now, if I talk about cuboid, in cuboid, length and breadth and height will be different. So that's why your volume will become now length into breadth into height. It does not matter whichever you take, which one, but length into breadth to height, correct? So tell me, Sanvi,
Yes, sir.
suppose I take this book, my favorite book, okay?
Yes, sir.
Suppose this is the length,
Yes.
this is the height,
Yes.
and this is the breadth. All three are different here.
Yes.
So
All
volume
three are
is
different.
L into B into H. Correct? Everybody knows that.
Yeah.
But if I tell you what is the area of front face, how much is the area of front face?
Sir, that also, I guess.
See, this
Oh.
is the length, this is the breadth.
Yes.
I said length is this. You can choose any two, length and breadth. This you can say height or width, whatever.
Yes, sir.
What will the area of this face? Length into breadth only, right?
Yes, sir. Length into
So when
breadth.
you see from the front, it look like as a rectangle, right?
Yes.
What will the area of the back face?
Same.
So length into breadth and length into 2 times length into breadth, right?
Yeah.
We got 2 times length into breadth. Now tell me,
Yes.
so we got 2 LB, right?
Yes, sir.
Now tell me, Ishant, what would be the area of this front top face? Ishant,
Yes, sir.
what would be the area of the top face? This one.
So of the book,
Yes, I am showing you this one. See, this is the book. I said this is the length, this is the breadth, and this is the height or width, whatever. So I am
okay,
talking about the top one now. It will be breadth into height, right?
height.
It will be breadth into height, right?
Yes.
What would be the area of the bottom face? This one.
So it will be same as
It will
top.
be same. So we got again 2 more, 2 times of BH, right?
Yes.
Now tell me, Pratibha, tell me, what is the area of the side face? Pratibha, are you there? Gauri, are you there?
Yes, sir.
What
Length
is the
and
area? Length into
height.
height. And what would be area of the right side face?
Same as that.
Same. So we covered all the 6 faces, right?
Yes, sir.
So tell me, everybody, if we add all 3 together, we get the total surface area of cuboid or not? Area of this, 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 area of this. And that is what a formula is. 2 times LB plus 2BH plus 2LH. Correct?
Sir, what is the formula of lateral surface area?
I am coming to that, Gauri. Coming to that. Actually, you all can find out now because I told you the concept. Now, in lateral surface area, tell me, Gauri, which of the faces will not come?
Sir, top and bottom.
Top and bottom. So, top and bottom for us was this, right? 2BH.
Yes, sir.
So, that will not come. So, it will become 2LB plus 2LH or not?
LH.
That's it.
Yes, sir.
So, if I take 2 out, if I take L out, what it becomes? That is the formula. So, nobody has to mug this because question in higher competitive exam or any little higher level exam, nobody will do direct questions, right? This is what your LSA, this is what your TSA. Any doubt? Because we are going to solve 2 questions now. Any question, anybody?
No, sir.
No question at all, right? Are you ready to solve a question now? So we will take a question of Shweta ma'am's house, okay? Okay? See carefully, everybody. Shweta has a beautiful house. Okay. Shweta has a beautiful house. Dimensions are, again I am taking some what is a random dimension, 10 by 15 by 10, 15 by 12. You can assume length and height, I don't mind. 15 is the height, 10 and 12 are meters. Okay, this is the dimension of her beautiful house, or you can say one drawing room. Okay, this is the dimension of a drawing room. Okay, now she want to get painted the drawing room, except obviously we will not write except floor. Nobody will get painted floor, right? Actually, I should not say that. So you can assume that drawing room. Obviously, you will paint the roof, but you will not paint the floor, right? But maybe we'll ask her what about floor. So now she has two. So I'll not say she has. Drawing room has two doors of 5 by 5 by 5 by, if it is 8, 5 by 10. How many windows, Shweta?
I have two big windows, almost
big
one
window.
in the window.
We'll say one window dimension is say 6. Anyway, it's just 6 by 4, and I'll say big one 8 by 6, just to make it different. Okay. She also has some kind of she has a projector screen fixed. You cannot remove that. Projector screen of dimension say 10, so 8 by 8, because it's for her it's a, you can say like kind of a studio kind of thing. Okay. What else you want to put here, Shweta?
Sir, it's nothing like I have a big window. Even I have a window, like I have a door also between window.
Okay. And she has some beautiful paintings. Okay, I'll put that. She has beautiful paintings. She will not remove that for painting. Whatever. She has beautiful paintings. 5 paintings. So 3 square paintings.
So many, so many things. It will be a very
Outside,
question for children.
outside 3 meters, and 2 rectangular painting. I want them to think more. 2 rectangular painting. If everybody can solve this question, then all easy.
Yeah, I just like first we have to find out
2 rectangular painting of 4 by
first,
6.
you know,
You are
these
right.
small bits, and then we find out the bigger bit.
Rate of painting is. Tell me how much rate they charge. Rate of painting is dollar or pound, whatever. Should I put dollar, pound, or rupees in India? Okay, rupees 100 per square meter. You have to just a question very simple. How much it will cost her? That's it. Simple 4 words question. How much will it cost her? You have to find out how much cost she has to bear for painting her drawing room. Everybody, it's a cuboid, as you know by dimension, right? Can you solve, guys? It's very easy.
Shall we start together, because it will be difficult for children, sir?
Sure.
Yeah. Okay. Who wants to join in? Let's figure out all the small bits first. Yeah.
Yes.
Like we have a room. Let's find out the surface of the area of the room, doors,
So,
windows.
So first you'll say total area of drawing room.
Yeah. Total area of drawing room is 10 by 15 by 12. So it will be 150.
But that is the volume. No, so that's why I gave this question, because what happens, Srita, now is we don't want volume. We want walls. So we cannot take TSA, we cannot take LSA. You take something in between. So you have to think, guys,
so
everybody. Yes.
Take a lateral surface, sir. We will take a lateral
LSA
surface.
plus
The roof, only the one roof.
Exactly. That's the point. So,
So
guys,
it-
understood what she said? You'll take first lateral surface, all the 4 walls, LSA, plus the ceiling.
only the ceiling, yes. So it's 10 by 15 by 12 room. So here we
area.
have to do like 4 times.
So, yeah, or you can do this like 2 into, suppose the front and back wall, 10 into 15, whichever. We are assuming, okay, everything will come into picture except your floor. That's it.
Yes. So the lateral surface will be to length into breadth. So length is, I guess, 15 and breadth is 10 and height is 12, right? Is that way we're going?
So, yeah, so obviously here in this height is 15 and length is 12.
Oh, height is 15 meters, right?
Actually, you can assume one of that. So, which one you say this is the height?
Yeah, that's fine. No, it's like a palace then.
That's why I know you are in palace only. Okay, this is height. Length of bread, you can take anything, doesn't matter.
Yeah, doesn't matter. So let it be this way. So we take the area length 2L B plus H. That's the right formula to use it.
Correct. Right, guys? 50 into 12, 6 into 600. 600 square meters, right? This is the total area only for the 4 walls.
Yes, is the area for 4 walls. Now we have to figure out the roof. So
Roof.
we know the length and breadth is 10 by 12. So it's 120.
Yes, area of roof only length of bed comes to 120.
Ritesh has already calculated. Very good, Ritesh.
720 square meters.
Yes.
Is the area of the
Roof.
so no, I add both. So area of drawing room is 720. But that is not the area to be painted, right? Because we have to remove the all walls and all your doors, paintings, projector, all those, right?
Yes. So we have to now calculate the small bits. Like drawing room has 2 doors. So we have to find the surface area for that. The surface area for the door
It's a
will be
rectangle,
5.
right? It's
That's
a
right.
rectangle.
So it's 50.
50. So 50 into 2.
Yeah.
Because there are 2.
2
So
doors.
doors are 100 square meters.
Square meter.
Then
Right.
windows.
Windows. We have got 2 windows. One is 6 by 4 and 8 by 6. 6 by 4 is 24 and 8 by 6 is 30.
48. So
48.
72 is that.
72 square meter.
Actually, this
Now-
question is not difficult. If people know the concept, it's,
Just like we have to calculate all the bits.
that's
And
it.
now she has got the projector. So projector is 8 by 8, which is not going to be removed. So 8 times 8 is 64.
64 square meter. Okay.
Now-
Paintings.
Painting. So there are 5 paintings. 3 painting are square, which is 3
Take
meters.
square paintings, yeah.
So 3 times, bracket me 3 times 3. So 3 by 3 is 9, 27.
Superb.
Now we take the 2 rectangular painting, which are 4 by 6. So 4 times 6, 24 times 2, 48.
So why you calculate everything? Because you have to finally subtract, right?
Now we have to add all these things and take off from 120 because we can't paint them. We can't paint doors, windows, projectors and paintings. We can't paint them.
Yes.
That's why we have to take them out of the
So it is
total.
100, 172, 178 and 60, 88, 98, 238, 245, 265, 265 and 8, 273 and 40. 273 and 40 is how much? 83, 93, 323 I think. Or 313, how much? 313, I forgot what I was doing.
It's 172 plus 64, 70 plus 60.
Sir,
That's fine, Ritesh.
sir,
Tell
we
me.
should add even 720.
No, 720 is different. 720 is the total area of room. That will go
Total
in the
area.
end.
So we should add only from doors till the painting rectangle.
And don't ask me, and Sanvi,
Yes,
don't
sir.
ask me because objective is not to solve the question, objective to understand. You tell me which one you should take. Why we are adding this? Because she clearly said we have to remove this because we will not paint that. So from the total area of the room, we'll remove this all.
It's simple like this. We have a total this surface. Now
So
this window we want to paint. So we have to find this area. Now we have a proper square window. It's a different way. Just I'm explaining you. So we just find out the area which need to be painted.
Okay.
Yeah.
Thank you, ma'am.
So it is 311.
So wait, 2, 6, 13.
Sir, doors we have, why door is 30 square meter? It should be 100.
How much doors I have put? Doors.
100 it
2
is,
doors of. I put something wrong. No, I think it's become now. It is 50, 100, right? Yes. Right. It is 311, right? Kripa?
The children are saying 411. Gauri said 411. I didn't calculate it. Let me see.
It's 311. I calculated.
Yes, sir. It's 311.
311.
I thought what happened to my maths. Okay, 311. Okay, I was 311 square meter. So what is 311 square meter? The area which is not to be painted, correct?
Right.
So now I need a space here. Let me put that here. Okay, this is here. 1 second. So how much is area to be painted now? We will just subtract from 720, right?
Sir, 409 square meter.
So 720. So I'll write here area to be painted. Area to be painted is 720 minus 311, which is very easy. 7 and 3 is 4, 20 minus 11 is 9. Correct?
Yes.
So good, Shweta, you have saved so much amount to be painted because of this all.
Of these things, yes.
So 409 square meter. Now what will do last? Who will tell me? Not Shweta. Who will tell me this is the area to be painted? How much cost you will bear?
Sir, Kripa speaking.
Yes.
Sir, like it's given us rate of painting is rupees 100 per square meter, and we have 409 square meters, so we gonna multiply it with 100.
That's it.
So we get 40,900.
So less
Right.
rupees. That's it. So tell me now, if you just go by formula, you will not do this question. You will say, oh, LSA or TSA, LA or TSA, right? That's why I never want people to mug the formula because, and obviously this is again an easy question. Question can be twisted.
It is lengthy, but it is easy. It is lengthy.
Yeah, you just think what to paint, what not to paint. Shall we do one more question which require more imagination? Very beautiful question. We'll do today cuboid only then.
Manvi looks tired today.
Hope nobody's doubt, right?
Yes, sir.
Yes, please.
So have you added a roof?
No, sweetie.
Roof is already added to the 720, right?
Oh.
Yeah, 600 plus 120. We add roof already, but we'll not add the you can say floor. Okay. Let's try one more question now. You will all laugh, what, sir? But that is what I want you to imagine a lot. Okay. A L-shaped block is made which is fixed on the ground. Okay. This time you have to solve. I will not help. Neither Shweta will help, please. I want everybody to imagine more. These all are made of the same blocks. Same like. Oh, so like that, suppose a 1, 2, how many you need? No formula will work here. You have a L-shaped figure you made, which is fixed on the ground, which is made of 1, 2, 3, total 6 blocks like this and 3 blocks like this. Okay, guys. And all blocks are same. They are made of the 6 those pieces. So 6, you can say 6 cubes. So how many? 1, 2, 3, 4, 5, 6, 7, and 9. Question is like this: 9 cubes of side 5 centimeters are joined to form L as shown. Okay, Kripa, don't get tensed. It's okay. 9 cubes of side 5 centimeters joined to form L as shown. Hridaya want to paint only the visible faces, and this L is fixed on the ground like this. Okay, not on the wall. It is like somewhere in the middle of somewhere on the visible faces. Cost of rate of painting is easy question, rupees 100 per square meter. Tell me how much cost will take to paint the L. Tell me what the best way. No formula will work here. You have to think little more. Who want to try? Everybody will try, but tell me the method.
Sir, I think it's like Ridya wants to paint only the visible faces, and as it's stuck to the ground, so the back face will not be visible as it's stuck.
It is visible. Not the back will be visible. Bottom will not be visible. Like this. It's like this.
Okay, like this, not like
This
this.
is visible. It is not on the wall. It is on the ground center of her room.
So there will
Say on
be.
a table. Say on a table. She has a table, on that she has put like this L.
Okay, like this.
Yes.
So it will be like 5 faces, which is visible because it's stuck.
I'm not going to tell you that. That you have to imagine. Hridaya, you asked a very difficult question. Is it? Right? How will
Yes,
and question is not difficult, guys. You have to just imagine. Siona, Pratibha, Ritesh, just come in with your thoughts. That's it. First thing is no formulas, because I want you to imagine more. Everybody.
sir.
Instead of telling, yes, tell me.
So can I explain the question once more? I didn't understand.
See, Hridaya, want to explain? You want to explain?
Okay, sir.
No, you asked me to explain, or you said you want to explain?
You want to explain.
I'll explain anyway. So I'll give a hint, everybody. Don't try to calculate the area. Just calculate, don't calculate area of a particular square also. No. Just calculate number of faces to be visible. That is more easy. Number of total faces. See, like Kripa or everybody, if you look from front, how many faces are visible? Everything. 9. All 9, right? From back also, all 9. From the top, from the bottom, from the left, from the right. See, look from there, add all. So total number of faces, you know how much visible. And then multiply with area of one face. That's the best way to solve.
Okay, sir.
Faces visible. I'll start writing, and everybody got the answer or method. Faces visible. From top. No, from front. Tell me how much.
$32 faces, I guess, sir. Is 32?
Okay, let me check. I have not counted yet because I still want people to find out.
45.
Ritesh said 34. Somebody saying 45. And that is the only main problem. Otherwise, it's very easy.
I guess it's 32, sir.
So from the front, 9. From the back, 9. From top. Now the problem comes. From top. 1, 2, 3 and 4.
It's 34, sir.
Is it? Okay. From top, 4. From bottom, nothing. Correct? Left side. From left, if I see from left, it would be 1, 2, 3, 4, 5 and 6. If I see from the right, again 6. (34) is correct. So one we know total number 34 faces are visible. Face. Each face is how much? Square, right? Each face is square. And it is 5 centimeter. So area of one face is 5 into 5, 25. And total area would be this much. And cost is 100. This will be your answer. 25 into 34 into 100. 25 into 34 is 17. 17 half is 8.5. 8.5 into 100. 850.
Sir, 85,000.
That's it.
850.
So
No,
tell me, 85,000 is right. So it will cost 85,000 Hridaya just for your one toy. See? So tell me, was it a difficult question or just imagination required?
Imagination required, sir.
And you get this kind of question in Olympiads and even difficult examples, right? They'll be some kind of figure and you have to imagine which is visible, which is not visible, what shape it is. So though it's a cuboid, but we solve using the cube. Tell me, no, your TSA, LSA formula will work here? No, right? Because you will say, oh, should I take TSA, LSA? No, it's a concept only. Start imagining what kind of shape. That's it. Easy?
Yes.
Good.
Sir, I think I want to join that Olympiad, that class too. Then it will be very easy for me to attend this class.
And anyway, you are going to attend my next week Olympiad, so don't worry. Vidya, so we'll do anyway a lot of fun on that.
Sir, we attended the Olympiad. Other than that, other Olympiad was same.
I am telling Hridaya, not to you. Hridaya is not attended, that's why. Level 2 will come later, not now. That is level 1, okay?
Sir,
Any question?
algebra?
Algebra not next week. No, I reduced. I'll do only 5 courses in a week. And I'll reduce again next time 4 only. Because I want to take some rest. A lot of classes are happening. And my classes are happening till night 11:30, you know. So I want to reduce now. So I am reducing one by one. Every week one reduce. So I started with 7 classes in a week. Means every day. Then I did 6. Then I did, no, I'm doing 5 only. Next week I'll do only 4 then. Like this. Only 4 top courses, okay? Right, Kripa? Imagination required. Yep, yes. So what we'll do tomorrow is, tomorrow we will work on cylinder and cone because that is the most popular topic in your 3D. Cube cuboid is fine. Now I'll give you one more formula. What is principal diagonal means? Principal diagonal is this. You already understood? Principal diagonal is given by the length. Principal diagonal length is given by like this. Is given by this. Everybody note down this. Length square plus breadth square. Suppose somebody asks you plus height square. Okay? Remember Kripa wanted to put her big rod in your room, Sanvi, right?
Yes, sir.
If suppose Kripa asks you what is the biggest size or length of rod she can put in your room of size 10, let's make it small, 3 into 4 into 5 centimeter. So what will you answer? Question is, she want to find out what is the biggest length of rod she can put in your room of size 3 into 4 into 5. So obviously the way is you have to do diagonal only, right? Otherwise you cannot put, right?
Yes, sir.
So you'll find what is the principal diagonal of your room. The principal diagonal is given by L square plus B square square. So you'll say,
Sir, I guess 24
3
cm.
square is 9. 4 square is 16, not 24. And 5 square is 25, correct?
Yes.
This is root of 50. Root of 50 is 5 root 2. So
Yes.
length is 5 root 2 or root 2 is 1.414. Multiply 5 with 1.414. You get what is the length of the rod she can put. Root is 1.414. 5 root, okay? 2 root, right? You attended my Vedic Maths Senior, I explained how to find root, right?
Yes, sir.
5 into 1.414. 1.4 into 5 is 14, 10, 40, 0.7. Approximately 0.728.
Yes.
So 7.28, not this. 7.28. 7.28 meter rod only you can put, Kripa. Don't bring more than that. Got it? So if a room, see now what Shiva explaining, Shweta, is clear, right? See, though your room size is only 3, 4 and 5, but still you can put the rod of like 7.28 meter because you are putting in the principal diagonal. If you would have put it this diagonal, it would be lesser than that. Getting it? The concept? That's kind of question. Okay? Okay. So this kind of question you can get lot of. It requires imagination. See, I'll tell you cuboid, nothing else. If you know the volume, if you know the surface area, and if you know the principal diagonal, any level you will not get, because they know the concept. Any question you can solve. It's all imagination. These are the 3 things you need. Okay? That's all. Tell me anything you want to say. Anybody, anything want to say? I'm done.
Sir,
Yes, please.
sir, in maths, because of that subject only, like the perimeter and area is my worst subject in maths.
So that's why, Hridaya, see, today you understood something. Tomorrow we'll do about round figure. Today we do lateral figures. Tomorrow we do cylinder and cone. Whole 1 hour will spend only in cylinder and cone. So it will be crystal clear because I am going to explain practically that how this surface area is formed, how volume is formed. Will not mug the formula. I'll explain you the how it happens. You have to imagine. Come with one bangle and one bangle is enough. Okay? Or some
Sir?
small disc. Yes, please.
Sir, how 5 by 2 came?
Root 50, right?
Yes, sir.
25, 69 is how much? 50?
Yes.
Square root of 50. I cannot find. 50 means what? 25 into 2?
Yes, sir.
25 outside take 5 only, right?
Yes, I got it.
Got it.
So,
Yes, please.
Sir, is this enough?
Yeah. This is good. Bring that. This is called as what you call.
Yeah,
in,
for wire and door we use.
Yeah. Anyway, I'll use this example tomorrow.
electric tape.
That tape is also very. That is called embarkment. What is
Yeah.
called embarkment? And believe me, lot of kids doesn't understand what is embarkment. So bring this tape tomorrow. Yeah, it's an embarkment.
So,
Okay. Yes, please.
So when you do after, like you said, every week you reduce one class. So every week later, then you'll have only one class. Then you restart with 7 classes or what?
No, I'm not getting time to eat also, because what is happening is when I do 7 classes and then I do 1-to-1 classes also, lot of 1-to-1 classes. Lot of people, my friends' kids, my friends' kids, they want to. So I am doing, 2 class per week. So I made 4 or 5 different batches. So my whole night is booked. So what happening is, so this daytime I want. So no, I'm changing my time of life. Like I'll do classes from afternoon 1 to night 1. That's the thing I'm trying to do now. Okay, so not 7, but again, all your courses anyway you're done, so nothing to worry. We'll do all popular courses. So only thing is what happens is you will wait for next 1 week. That's it, or 2 weeks. Okay, nothing else. That's all, guys. Any comments? Anything anybody want to say? If not, then finally Shweta will say it. We'll close. Anybody? Anything? See.
No, sir.
Okay. So thank you all. Tell me, Shweta, any closing comments you have?
Thank you. It's a lovely class and really learned a lot about geometry. I was asking my son, me this year you will be learning all this. At least you will get an intro, but he doesn't want.
And geometry is huge, you know. Geometry is really,
And
really
they
huge.
said they will be doing all this.
Yes.
So I asked him to join this class, but he said, no, I don't want to.
No, for him, still he's too young.
Yeah. But you know, I'm preparing him for some competitive exams. In that, they will be covering 2 years ahead of their syllabus.
Sure. Let me know any help you need. For
Yes,
me, you are more a partner, so nothing to. You can always.
Yes. So definitely, maybe
Yes,
when
yes.
he's ready to learn, then I will join him.
Sure. So thank you, everyone. We'll meet tomorrow for the last class. Yeah. Bye.
Thank you, sir. Bye.
Bye, sir.
Bye, sir.
Thank you.
Bye, sir.
Thank you, sir.
Thank you, sir.
Thank you.